Hello, Math Humans. We're going to do 6.1 today. We're going to be starting one of our bonus chapters, and we're going to be talking about graph theory. So the objectives are that we're going to understand and use graph theory. So let's talk about what graph theory is. It's routing and network problems. So for example, I want to find the best route. I want to find a route that has the least amount of time. Maybe I want to find the least expensive route. Examples of real-life applications could be UPS, trying to find out what route does a driver need to take to make sure that they can deliver all their packages in the most efficient manner. Same thing for the U.S. Postal Service, meter readers, manufacturing. One of the things that sometimes manufacturing wants to make sure is that paths don't cross. So people pushing carts for one product don't run into people pushing carts for another product. Railway systems would be a bummer if trains crashed. But what's the most efficient way to get trains from point A to point B? Computer chips and then telephone networks. So those are just some examples. So let's talk about what graph theory actually looks like. So let's say I have, this is A, and maybe this is B, and then we'll call this guy C, and I'm going to just scribble them in. And those are going to be, the dots are going to be the vertices, okay? And so the vertices represent a location, okay, of something. Maybe it's a location of information. Maybe it's a location of cell phone towers. Maybe it is a location of where train stations are. And so let's say then I have these paths in between, and then maybe this guy has a circular path. So a next word that we need to remember or need to know are what's called edges. And the edges are the lines that connect, my coffee's in the way, the vertices or the dots, okay? All right, I can have something called a multiple edge, so multiple edges, and maybe multiple edges are two or more lines from the same dot. Okay, and I'll move my paper up in just a sec. There we go. All right, so on here, my vertices are A, B, and C. So I would say that my vertices are A, B, and C. And I have edges. So for my edges, I have A to B, I have B to C, and I have C to A. And then I also have A to A, and that's this little guy right here, okay? The next phrase that we want to understand is connected. And a connected line would be lines from one, that's a one, can't write, one dot or vertices to all vertices. So maybe for the connected, maybe I have, here's an A, and A goes out to all of my individual other vertices. So maybe B, C, D, E, and F. So maybe that's a hub, like an airplane, which would be kind of entertaining. And then disconnected means that the lines can't get to a dot or a vertices. Okay, and so we'll use those kind of words interchangeably. So for the next thing that we're going to do, we're going to have a little network. Okay, so for example, 1, I'm going to put V here, and then I'm going to put a U up here, and then I'm going to put a W, and then I'm going to put over here a Z. And we're always going to be given the paths. So we have V to U, U to W, W to Z, Z to W, V to W, and V to V. Okay, so let's just talk about what we know. I know that I have vertices of U, V, W, and Z. My edges are going to be V to U, and then I'm going to have U to W, W to Z, and then I'm going to do Z to W. Okay, so maybe we'll call that guy 1 and that guy 2. And then at V, I'm going to have V to V. Okay, it is a connected graph, meaning that there aren't any gaps in our network. Okay, and then I'm going to say for multiple edges, oops, spelled it wrong, I'm going to have W to Z, right? So maybe I have W to Z going method 1, and maybe I have W to Z going method 2. Alrighty? So that's kind of the beginning of a network, and we're going to do a lot more with that as we move through the chapter. So the next thing that I want to talk about is just the terminology, because we have a lot of definitions as we talk about our graph theory. The first one is the order of a network. So the order is the number of vertices in the entire network. So if you think about the example that we just did, we had 1, 2, 3, 4. So in our last example, the order would have been 4 because I had 4 different vertices. Okay? Adjacent vertices are 2 vertices that are connected by an edge. So in our last example, for example, some of my adjacent vertices would have been V to U, would have been U to W, would have been W to Z, would have been V to W. Those would be adjacent vertices, meaning they're connected by an edge. Adjacent edges would be 2 edges that share a common vertex. So in this one, for my adjacent edges, and again, I'm using the last example, maybe I had VW, that's a W, and WZ because they both shared a common vertex W. The degree of a vertex means the number of edges at a vertex. So if you go back to our last example and you look at the vertex W, it had 1, 2, 3, 4, and so it would have been, W would have been 4th degree, meaning that there are 4 paths coming out of 4 edges coming out of our vertex. A path is a sequence of vertices with each vertex adjacent to the next one. Here's the key piece on a path. It starts and ends at a different vertex, okay? So for a path, that would be a series of edges that moves us through the network, but they start and end at a different vertex. And you can only touch each edge once. So those are the 2 critical pieces of information for a path. The next one is a circuit. So a circuit is a path. So remember, a path is going to take us from maybe point A to point B, right? It starts and ends at different vertices, and it's going to hit every edge only once. A circuit is going to start and end at the same vertex. So very important, the difference between a path and a circuit is going to start and end at the same vertex. And then our last definition is a bridge. And a bridge is an edge that if it were removed, the graph would become disconnected. Alrighty, so a lot of definitions. So let's go ahead and work through this example, and we're just going to talk about some of our vocabulary words. Alright, so I have 1, 2, 3, 4, 5, 6. So the order of my network would be 6 because there are 6 vertices. Okay, and if I needed to, I could list them: A, B, C, D, E, and F. Okay. Alrighty, the next thing that I want to talk about is just some interesting information. At vertex A, it is a degree of 4 because I have 1, 2, 3, 4. I'm going to label them 1, 2, 3, 4 paths that come out, or 4 edges. Sorry, bad choice of words. 4 edges that come out of A. B is a 1, 2, 3, 4. So B is a 4th degree. Okay. If I have F, F is only a 2nd degree. And if I do one more, let's say I do E, it is 1, 2, 3, 4. It is also a 4th degree. Okay? All right. If I use other of the words that we just learned on our previous page of notes, A is going to be adjacent to, and it's going to be B, C, D, and E. Adjacent means I can go from A to B, A to D, A to E, A to C. Okay. F is adjacent to, and F is going to be adjacent to C and D. And then I can look at edges. So my edge DF is adjacent to, so my vertices can be adjacent and my edges can be adjacent, is adjacent to, and it could be BD, A, D, C, F, and D, E. Okay? Let's see, what else? So let's say I want to pick a path. So just as we look at a variety of different things, if I can keep it in there. So maybe some of our paths could be A, and I could go to B, and I could go to D. Or maybe I could do A, B, and then C, and then E, right? So I went A to B, B to C, C to E. Or maybe I do a longer path, and I go F, D, E, B, C. So I can't skip vertices. Okay, so a circuit, remember, is going to be where I start and end at the same place. Oh, you've got the diagram on your paper, so maybe you can see it. So maybe a circuit would be B, A, D, B. So if I look, B, A, D, B. Remember, a circuit is going to start and end at the same place. Maybe another one could be B, C, F, D, B. So I went B, C, F, D, B. Remember, I can only touch each edge once. And then the last thing that I would point out for this particular network or graph, there are none. There are no bridges. I can't take out anything without making my circuit incomplete. Okay? All right, that's it for today. Kind of a fun introduction into graph theory. I will see you soon.